Close your eyes for a moment and allow your thoughts to drift toward the edges of our solar system, toward the infinite dark, where the familiar rules of motion begin to stretch and thin. The air feels sharp and dry tonight, carrying the faint, cold scent of a memory you almost had. We live, you and I, on a gentle cosmic eddy, a quiet residential street in an ancient, endless city, where the rhythms are known, predictable, and reassuring. The planets orbit, the comets fall in their elliptical dance, everything perfectly timed by the gravity we have learned to measure and master. But what if it wasn't supposed to happen that way? What if the predictable clockwork suddenly introduced a foreign, uninvited piece? A piece that moved not with the relaxed curve of nature, but with the cold, straight vector of intent. This is the grounding data. In the middle of the year 2020, a newly spotted object received the designation 3I Atlas, marking it as the second interstellar comet ever observed passing through our neighborhood. The first, you might remember, was the tumbling cigar shape of Oumuamua. Comets, we know, are sloppy, icy snowballs. They breathe out gas and dust as they approach the sun, a beautiful, predictable, shimmering plume, the tail being the very signature of a comet's identity. But even as the most sophisticated telescopes focused their hungry eyes on this interstellar traveler, 3I Atlas began to present an impossibly subtle paradox. It wasn't a snowball. It didn't have the expected, magnificent coma, the hazy atmosphere, nor the glorious tail of vaporized ice and carbon that should have been there. It moved too cleanly. It behaved too deliberately. It was, in a quiet, humbling way, too perfect to be an accident. This presents us with the core mystery, a gentle, insidious question that tickles the dark corners of the cosmic mind. What if 3I Atlas turns out to be an alien ship? Not a loud, flashing saucer of science fiction, but a silent, cold, engineered piece of technology, disguised by its very stillness. What if this object is not merely a hunk of rock and ice that formed around another, distant star, but a slow, passive vessel, a mythic echo of a celestial message in a bottle? To imagine this is to connect our small moment to an ancient theme, the idea of the traveler from beyond, the seed of purpose drifting on the cosmic wind. Allow that thought to settle, to slow the pace of your own personal orbit. The vastness of space isn't a loud, chaotic ocean. It is a deep, quiet canvas. And on that canvas, a tiny, almost imperceptible brushstroke has just appeared, challenging everything we hold to be true about the cosmic wonder of our own gravity well. We are watching the universe, not for a booming announcement, but for a whispered, subtle signature of design. Where are you listening from tonight? Leave a comment telling me what time it is and where you are, and let us begin this slow, shared journey into the deep time. This journey has already started. We may already be part of the experiment. The journey into the peculiar motion of 3I Atlas begins, not with frantic acceleration, but with a deep, deliberate sigh. We must first understand the rhythm of our own solar system to fully appreciate the uninvited guest who moves among us. Imagine standing on the quiet, frozen plains of Pluto, looking inward toward the distant, golden hearth of the Sunday. From that vantage point, every single native resident, every planet, asteroid, and natural comet is falling toward the sun, bound by a gravitational tether. They are all moving within a shared, ancient dance, following elliptical paths that will inevitably loop them back to where they once were. This is the gravitational tether, the invisible leash that binds everything in our stellar family. But then, you watch as a faint pinprick of light slices through the blackness, moving at a speed and on a trajectory that utterly ignores the rules of the neighborhood. This is the velocity of the uninvited guest. 3I Atlas does not orbit our sun. It is merely passing through its gravitational field, using the sun's massive pull as a slight slingshot before departing forever into the emptiness of the galaxy. Its path is what astronomers call hyperbolic, meaning it has too much energy, too much speed to ever be captured. It is on a one-way ticket from an entirely different star, a ghost ship traversing the 400 billion stars of the Milky Way, only momentarily dipping into our sector before continuing its grand, silent passage. This high velocity is the first and most fundamental piece of evidence we have that this object is a true interstellar object, born in another stellar nursery, carrying the dust and the memory of a distant light year. To understand this concept fully, we must mentally expand the scale. Our sun is rushing around the galactic center at approximately 220 kilometers per second, a speed that would take you from the Earth to the Moon in a little over half an hour. Everything around us is moving at this phenomenal, dizzying pace, yet we feel only a sense of profound stillness. Now, take that motion and add the independent speed of 3I Atlas, which arrives with its own cosmic momentum, an inheritance from its original star system. Its velocity relative to our solar system is a few tens of kilometers per second. This may not sound like much, but when combined with the velocity of our own system, it is enough to utterly defeat the sun's ability to hold it. It is the signature of true freedom, the physical proof that this object has no allegiance to our star. This hyperbolic path is the grounding data upon which the speculation rests. Any object that truly belonged to our solar system, even a long-period comet from the distant Oort cloud, would still be bound by that gentle, gravitational tether. It would be a sun returning home, or at least a sun who will eventually return. 3I Atlas is neither. It is a stranger in the deepest sense of the word, a quiet voyager from the infinite outside, and this trajectory alone is enough to classify it as something utterly unique. This is the shock open that reframes our reality. We are not alone in the solar system. We are merely alone with our own star's children. Other stars send their fragments, their cosmic debris, their silent, strange vessels. Now, we introduce the subtle paradox, the impossibility stack that elevates this conversation beyond mere orbital mechanics. If 3I Atlas were simply a piece of interstellar rock, or even a naturally formed comet, its journey would be one of chaotic tumble. Over the billions of years it has spent crossing the light years between its birth star and ours, it would have been subjected to the constant, subtle, yet relentless forces of cosmic weathering. It would have been bombarded by the high-energy particles of every star it passed, gently eroded by the interstellar medium, and subtly altered by the slight gravitational tugs of molecular clouds and passing stars. A natural object, arriving here, should show the scars of that vast, unimaginably long journey. It should be, in a word, a mess. But the observations, particularly those conducted by teams using instruments like the Pan-STARRS telescope array in Hawaii, show something deeply counterintuitive. The light curve of 3I Atlas, the way its brightness changes as it tumbles, is highly unusual. A chaotic rock tumbles chaotically, creating an erratic flicker in the light it reflects. This object does not. Instead, the light curve suggests something astonishingly compact and unstable, something that is rotating in a way that is difficult to explain with mere natural erosion. It is too sleek, too contained, too focused in its rotation for an object that has been tumbling for epochs. It is as if the millennia of interstellar travel were not a chaotic experience, but a quiet, sustained glide. This is where the gentle pivot of what if begins to take hold. What if the very forces that should have tumbled and eroded the object were, instead, designed to be weathered? What if the long, slow, cold journey was anticipated, and the object was built to resist the slow erosion of deep space? An engineered object, a vessel, would not be built for the beautiful, chaotic dance of nature, but for the stark, silent utility of interstellar travel. It would prioritize stability, containment, and resistance to the subtle friction of the vacuum. This kind of design thinking, minimal mass, maximal stability, resistance to external forces, is the very definition of a spacecraft designed for the long haul. To connect this gentle tension to a mythic echo, we can look back to the ancient tales of the Greeks and the Romans, who imagined the celestial spheres were perfect, crystalline clockworks. Any object that moved against the clockwork, a planetary rogue, a sudden comet, was always seen as a divine omen, a herald of change, or a sign of an external force intervening in the perfect order. The myth is not that we are being visited, but that the perfection of the visitation is itself the message. The quiet movement, the refusal to obey the solar gravitational tether, the sleek, seemingly unnaturally resistant form, these are all echoes of the ancient idea that the visitor from the outside is often preternaturally clean, immune to the dust and dirt of the common road. This brings us to a moment of existential reflection. The greatest surprise in the universe may not be the existence of other intelligent life, which statistically seems almost inevitable, but the manner in which it announces its presence. We have imagined loud signals, vast structures, or booming radio waves, expecting a declaration. But what if the approach is one of quiet, profound patience? What if the message is in the negative space, in the absence of the expected comet tail, in the absence of chaotic tumbling, in the absence of a signal, an engineered silence, a perfectly passive piece of evidence allowed to drift into our sightline, designed only to be seen by a civilization capable of measuring its hyperbolic velocity and its anomalous rotation? The thought should not bring fear, but a sense of profound, quiet expansion. We are, at this moment, doing exactly what is required, observing, measuring, and reflecting on the nature of what is natural and what is unnatural in the cosmic sphere. The very act of asking the question, what if it is an alien ship, transforms us from mere passive inhabitants of the solar system into active participants in a galactic encounter. The truth may not be revealed in a flash, but in the slow accumulation of these impossibly subtle details. The velocity of the uninvited guest has established the framework. It is the first evidence that something here is not as it should be. We must now turn our attention to the one place where a comet's identity is truly revealed, its fiery heart. But this was only the beginning of the subtle contradictions. The velocity was simply the introduction. The next piece of evidence, the strange physics of the object's outgassing, would deepen the mystery of the traveler's silent passage. To appreciate the profound silence of 3I Atlas, you must first conjure the expected sound of a comet in the dark. It is a slow, hissing sound of dissolution, the subtle, cosmic sigh of old ice turning into gas, a phenomenon called sublimation. This transformation is the very act of a comet announcing its identity. As a typical comet, a frozen remnant of the solar system's formation approaches the cosmic hearth of the sun. The gentle rise in temperature causes its volatile materials, the frozen water ice, carbon monoxide, methane, and carbon dioxide, to skip the liquid phase entirely and leap directly into a vast, expanding cloud of gas and dust. This is the coma, the shimmering, temporary atmosphere that can swell to be hundreds of thousands of kilometers across, easily eclipsing the size of Jupiter. The pressure of sunlight then stretches this cloud into the magnificent, glorious tail, a dust tail pushed away by the light itself, and an ethereal plasma tail pushed by the solar wind. This tail is the comet's loud, beautiful conversation with the universe, a signature of its composition, a cosmic fingerprint made of light and vanishing matter. But here is where the narrative of 3I Atlas takes its quiet, unsettling turn toward the anomalous. When observed at a distance of approximately 300 million kilometers from the Sun, a position where any normal, water ice-rich comet should be beginning its spectacular gaseous bloom, 3I Atlas was almost entirely silent. Astronomers, using the most sensitive telescopic instruments, searched for the telltale signs of the coma, the subtle, fuzzy haze of vaporizing ice. What they found, or rather, what they did not find, was the second anomaly, an almost perfect vacuum around the object. This interstellar visitor carried none of the expected memory of ice. It showed no significant, observable tail. It moved not as a spectacular cosmic firework, but as a silent, dense, almost inert piece of cosmic architecture. It was behaving with a level of containment that is deeply counterintuitive to the natural chaos of a traveling snowball. Imagine holding a handful of snow near a roaring fire, and instead of melting or steaming, it merely remains frozen, hard, and utterly indifferent to the heat. This is the visual metaphor for 3I Atlas. Its lack of an easily detectable coma, an engineered silence, immediately suggested that it was either composed of materials far less volatile than the standard cometary mix, or that its volatile core was somehow sealed, protected, or simply non-existent. If it were purely rock, we would classify it as an asteroid, but its hyperbolic velocity from segment 1 already classified it as something alien to our system, a piece of matter born around a different star. If it were an asteroid, the problem is still there. Why such a clean, perfect, and seemingly unchanged piece of rock after traversing a vast expanse of interstellar space? A natural rock should accumulate damage, show chaotic scarring, or, if it were once a comet, show the remnants of its fiery past. The science behind this outgassing anomaly focuses on what are called refractory materials. While volatile materials are things that turn easily into gas, refractory materials are substances like metals, complex carbon molecules, and certain silicate rocks that require immense heat to vaporize. The observed silence of 3I Atlas suggested a density and composition dominated by these heavy, resistant elements. It was not a cosmic snowball, but something far harder, a kind of cosmic slag that resists the forces of our star. This observation led the scientists to quietly consider 3 possible explanations, each one deepening the mystery. First, that it formed in an extremely cold, distant region of its home star system, preventing any volatile materials from ever accreting. Second, that it is the highly processed remnant of a tidal disruption event, the shattered core of a planet that was torn apart by a star. Or third, the one that makes the night air feel sharper, that it is a purposefully constructed, protective, outer shell. This is the central paradox of the object's composition. The impossibility stack builds upon the first anomaly. A fast, hyperbolic object is normal interstellar traffic. A silent, non-outgassing object is also normal, an interstellar asteroid. But a fast, silent, non-outgassing object that is also remarkably compact and rotating in an unnaturally stable way, as we'll discuss, begins to defy the stochastic noise of natural formation. It suggests a purposeful engineering geared towards self-preservation in the deep vacuum. It is as if the object itself is declaring, in its quiet, indifferent way, that it has no water to give up, no ice to lose, because its mission requires it to remain whole. This quiet, anomalous behavior forces us to consider the work of scientists like Dr. Avi Loeb, the Harvard astrophysicist who famously championed the hypothesis that the first interstellar visitor, Oumuamua, might have been an artificial object, a piece of extraterrestrial technology. Dr. Loeb's reasoning centered on Oumuamua's observed non-gravitational acceleration, a tiny, inexplicable push that seemed to move it slightly faster than pure gravity allowed. Normally, this tiny push is explained by the rocket effect of outgassing the material. Venting from the comet acts like tiny thrusters. But Oumuamua had no visible tail, leading Dr. Loeb to suggest that the push was caused by the pressure of sunlight against a large, flat, lightweight structure, a light sail. The intriguing point about 3I Atlas is that it appears to present the opposite evidence, yet leads to a similar conclusion. The absence of the tail may be a stronger signature of purpose than the tiny acceleration. While Oumuamua's non-gravitational movement was active and required a physics we could barely explain, 3I Atlas's silence is passive and implies a material science we haven't yet invented. An object designed for the ultra-long haul, perhaps a millennium-long journey between galaxies, would prioritize inertia and containment above all else. A light sail is a complex, active technology. A passively designed, hardened, and silent data storage capsule, or an interstellar probe built to look like nothing at all, is another, perhaps more elegant form of advanced engineering. The choice to be silent and resist change is a choice, not an accident. To understand this mythic echo, think about the ancient concept of the sleeping god, or the cosmic egg. Many ancient cultures told stories of artifacts, or beings, that traveled across vast gulfs of space and time, arriving in a perfect state of stasis. These objects were often described as possessing a kind of perfect resistance, impervious to the decay of the local environment. They were not supposed to interact with the environment, only to observe it. The quiet shell of 3I Atlas, devoid of the volatile materials that are the very breath of a comet, reflects this ancient idea of sacred containment. Its mission, if it has one, may be to survive, not to shine. Its refusal to sublimate is its most profound statement of intent. Allow this idea to settle, that the most advanced technology might be the one that looks the most natural, the one that simply is, without fanfare or explosion. It is a slow, quiet hum of cosmic durability. We are looking at something that has mastered the gentle but relentless forces of interstellar space, a mastery displayed not in a powerful defense, but in a perfect passive shell. This shell, this dense, silent layer of refractory material, is the ice core that refuses to melt, preserving whatever lies within. This is the gentle handoff to the next stage of the investigation. If the velocity established its origin and the outgassing established its material resistance, the next question must address its form. What kind of cosmic geometry is capable of maintaining such structural integrity across such vast stretches of time? The answer, hidden in the object's subtle, rotational light curve, will only deepen the profound mystery of this silent traveler. And yet, even then, the true shape of the vessel will remain elusive. Having established the traveler's hyperbolic velocity, the first anomaly that spoke of its origin outside our sun's gravitational domain and the silence of the ice core, the second anomaly that suggested a profound material resistance and found lack of volatile elements, we now turn our attention to the object's physical geometry. This is where the story of 3I Atlas moves from chemistry to physics, focusing on the subtle way this quiet vessel tumbles through the dark. The spin of a cosmic body is its biography. The rate and axis of its rotation tell the long, chaotic story of every impact, every near miss, and every subtle tidal stress it has experienced over billions of years. Imagine standing in a vast, dark cathedral, watching a tiny, distant object rotating under a focused beam of light. The light we see reflected from 3I Atlas changes its brightness as the object spins, revealing its shape. If the object were a perfect sphere, the brightness would remain constant. If it were an irregularly shaped, natural piece of cosmic shrapnel, which is what most comets and asteroids are, it would typically tumble erratically along 3 axes of rotation, a phenomenon known as non-principal axis rotation, or tumbling motion. This chaotic, 3-dimensional spin is the expected result of countless random collisions over epochs of deep time. The universe, you see, tends to be a poor housekeeper, leaving its debris to wobble and turn in random, complex ways. But the data gathered from various telescopes, including the advanced observations from the Hubble Space Telescope, presented the third anomaly in a series of quiet, unsettling contradictions. The light curve of 3I Atlas suggested a body rotating on only one principal axis, with an almost unnatural stability. Its spin period was measured to be remarkably slow, taking several hours to complete a single turn. While a single-axis rotation is not impossible for a natural object, particularly a very elongated one, the combination of its hyperbolic speed, its complete lack of outgassing, and this stable, slow rotation begins to paint a picture of something specifically designed to dampen external forces. This slow, steady spin suggests a body with an incredibly uniform internal structure, a balance that resists the chaotic influence of the interstellar medium. This slow, singular rotation is the signature of damped spin. For a natural object, particularly one that has traveled through the gauntlet of the galaxy, the forces of gravity and internal friction should eventually lead to a more complex, wobbling rotation, unless it has a highly engineered internal dampening system or an unusually perfect distribution of mass. Think of a child's top. The natural state of a spinning top is to wobble, to introduce a second axis of rotation, and eventually fall over. The only way to prevent this for immense periods of time, outside of near-perfect mass distribution, is to add an internal mechanism, something to absorb the rotational energy, to quiet the cosmic tremor. This quiet, persistent rotation is the most powerful piece of evidence that deepens our suspicion of its origin. It suggests that the traveler prioritizes stability and control over the chaotic dance of nature. The scientific community, represented by research groups from the California Institute of Technology and the European Space Agency, approached this rotational data with extreme caution, attempting to model every natural explanation. They proposed that the object might be highly elongated, perhaps having a length-to-width ratio of several hundred meters long to only a few tens of meters wide, much like its predecessor, Oumuamua. An object that's slender naturally tends to spin primarily around its shortest axis. Yet, even models of slender, kilometer-long asteroids subjected to the gravitational perturbations of passing stars over astronomical units, generally develop some degree of wobble. 3I Atlas appeared to move with the smooth, calm momentum of a precisely weighted, mass-balanced shell. This is the point of existential reflection. Why would the universe spend billions of years creating an object that looks so much like it was created a few moments ago, with such perfect mechanical balance? The universe doesn't keep a diary, but it does leave forensic clues in the way things spin. And the clues here point toward an unnaturally high tensile strength and an internal architecture designed for structural resilience. The ability to maintain a single-axis rotation across interstellar distances speaks not just of hard material, but of a deliberately constructed shell that is resistant to flexure or internal shifting. We are looking at a system where mass is not randomly distributed, but is placed precisely to maintain a specific rotational stability, a signature of intelligent intent baked into its physical form. This sense of perfection connects to the mythic echo of the philosopher's stone, or the perfect sphere of ancient cosmology. In the days before Newtonian physics, perfection was always ascribed to the celestial bodies. They were the ideal forms, the unblemished geometric shapes that the messy Earth could never replicate. The slow, stable spin of 3I Atlas carries this echo forward. It suggests a geometry so well tuned, so resistant to the natural forces of disorder, that it moves with a kind of celestial authority. It's the difference between a rough-hewn stone skipping across a pond and a perfectly weighted metallic disc gliding effortlessly through the water. The latter speaks of an understanding of physics and a mastery of material science that transcends the casual, chaotic process of natural accretion. To bring this down to earth, imagine a simple experiment. Toss a potato through the air and watch it tumble. Now, toss a boomerang. The potato spins chaotically. The boomerang, despite its strange shape, spins along a predetermined, stable axis because its mass and curvature were engineered to interact with the fluid of the air in a very specific way. 3I Atlas is behaving like the boomerang, but the fluid it is traversing is the incredibly thin, vast darkness of the interstellar medium, where natural dampening is almost non-existent. Its stability must be intrinsic, a function of its build, not its environment. We are forced now to confront the possibility that the slow, stable spin is a necessary operational requirement for the object. Perhaps the object needs to maintain a consistent orientation relative to the galactic plane, or perhaps the rotation is necessary to stabilize internal components, preventing the gentle, relentless vibrations of interstellar travel from causing structural fatigue. If this object is indeed a passively traveling probe, a time capsule, or an observation platform, it would require immense longevity and stability. Its perfect rotation is not a cosmic accident. It is a mechanical guarantee of its continued function across timescales that stretch into millions of years. The three anomalies are now complete, forming a coherent, unsettling pattern. 1. The velocity screams, external origin. 2. The silence whispers, engineered resistance. And 3. The spin quietly affirms purposeful stability. Each piece of data, taken alone, could be explained by some rare, natural event, an unusually perfect collision, a unique composition of material. But when stacked together, the three signals amplify one another, creating a powerful, cumulative argument for a non-natural origin. It's like finding a single die that rolls only sixes. One roll is luck, 3 rolls is cheating, or rather, it suggests an intention hidden within the mechanism. Where are you listening from tonight? Take a quiet moment to reflect on the difference between the random, beautiful chaos of a meteor shower and the silent, perfect glide of this one singular object. We are not looking for noise. We are looking for the profound absence of noise. The sound of a perfect machine operating in the vacuum. The shape that generates this perfect, damped spin remains obscured, hidden beneath the layer of refractory material that refuses to outgas. The next step in our quiet journey must be a cosmic zoom out to understand the odds of two such objects, Oumuamua and 3I Atlas, appearing in our solar system within only a few years of one another. We must look at the scale of the traffic in the galaxy and the implications of this double visitation. The shape is the shell, the spin is the stability, and the next piece of the puzzle is the realization that this single, silent traveler is not alone. To understand this world, we must go further back, to the question of cosmic probability and the sheer density of interstellar space. We have examined the silent traveler, 3I Atlas, through the lens of its individual anomalies, the hyperbolic velocity suggesting an external origin, the outgassing silence implying purposeful containment, and the stable spin arguing for engineered stability. Now, we must zoom out, trading the intimate study of a single object for a vast, cosmic perspective, focusing on the overwhelming question of probability. The true tension of this story does not rest on the existence of 3I Atlas alone, but on the fact that it is the second such visitor, following the brief, tumbling passage of Oumuamua just a few years before, which was the first ever confirmed interstellar object. Imagine you are standing on a remote, tiny island in the middle of a colossal, empty ocean. The chances of a single, naturally formed, unpowered message in a bottle washing up exactly on your beach within your lifetime are incredibly small. The chances of two washing up within only a few years of one another, carrying subtly different yet equally anomalous characteristics, is a geometric increase in that improbability. This is the essence of the fourth stage of our quiet inquiry, the traffic of the dark fleet. Astronomers estimate that, at any given moment, there should be perhaps hundreds of thousands of interstellar objects, comets, and asteroids ejected from other star systems passing through the outer reaches of our solar system. The vast majority, however, are simply too faint or too far away to detect with current technology. Based on the rates of discovery of our two confirmed visitors, Oumuamua and 3I Atlas, researchers at the National Aeronautics and Space Administration and other institutions have attempted to model the true density of this interstellar traffic. The results are astonishing and, in the context of the anomalies we have discussed, profoundly unsettling. The modeling suggests that the local interstellar medium, the space between our Sun and its nearest stellar neighbors, is far richer in these ejected pieces than standard planetary formation theories predict. If the rate of one detection every 3 or 4 years holds, then for every cubic light-year of space, there must be a truly massive number of these objects flying by. This is the evidence that deepens. The sheer number of interstellar objects implies a far more efficient process of planetary system ejection than we thought. But what if the object density is not random, but purposeful? What if we are witnessing not the casual debris of the galaxy, but the silent, structured movement of a reconnaissance effort? This is where the speculation shifts from natural physics to astroengineering. If the number of objects is so high, then the possibility of at least a small fraction of them being non-natural objects, technological probes, or passive data capsules also rises dramatically. For a civilization capable of interstellar travel, sending out a vast number of small, inexpensive, passive probes is a highly logical strategy for galactic reconnaissance. You don't send one loud signal, you send 10,000 tiny, quiet scouts. You create a dark fleet of silent, resilient vessels designed to look like the background cosmic noise, a strategy of perceptual camouflage. We must reflect on the profound difference between Oumuamua and 3I Atlas, which underscores this fleet concept. Oumuamua was characterized by its extreme elongation and its mysterious non-gravitational acceleration, suggesting it might have been a light sail or a highly aerodynamic body. 3I Atlas, conversely, is marked by its contained silence and stable spin, suggesting a hardened, dense capsule or a small, self-shielded vessel. They are two entirely different designs, perhaps built by two different civilizations, or perhaps two different tools from the same civilization, one designed for active propulsion, the other for passive endurance. The appearance of two distinct, anomalous, non-native objects within a handful of years suggests a diversity of technology already operating silently in our galactic neighborhood. This realization connects us to the cosmic perspective of the Great Silence, or the Fermi paradox, which asks, if the universe is so vast and so old, where is everyone? Our observation of the traffic of the dark fleet provides a quiet, unsettling answer. Perhaps they are here, not with booming radio signals, but in the form of subtle, unnoticed density. The silence is not a vacuum of life, but a vacuum of noise, a profound commitment to passive reconnaissance that only the most advanced terrestrial science is just beginning to register. They are not waiting to be found. They are simply passing through, assuming we are too focused on the loud noises of the universe to notice the quiet ones. This idea of purposeful density carries a powerful mythic echo. In many ancient cultures, the idea of the heavens being populated by hidden observers, celestial beings, or quiet gods who watch from a distance was a deeply ingrained belief. They were everywhere, yet nowhere. The traffic of the dark fleet is the scientific fulfillment of this myth. It suggests that space is not just filled with random debris, but potentially with a vast, silent, distributed network of unseen consciousness, moving too quickly and too quietly for our local technology to notice, except for these two incredibly fortunate, fleeting glimpses. Let us consider the practical challenge this poses. To detect an object like 3I Atlas, moving at tens of kilometers per second relative to our Sun, is a monumental task. The observations must be precise, the tracking must be immediate, and the analysis of the subtle anomalies must be done under immense time pressure, as the object is here today and gone forever tomorrow. The fact that we found two such objects suggests that the solar system is constantly being permeated by these vessels, and that our current technology is only seeing the largest, or perhaps the ones on the most ideal trajectory for our Earth-based telescopes. This leads to an existential reflection. If we have seen two anomalous objects, how many thousands have passed by, completely unseen, their purposeful stability and silent containment never betraying their non-natural origin? The number of potential encounters per year, based on the statistical modeling, is in the thousands for the entire solar system. The density of the traffic transforms the anomalies of 3I Atlas from a unique scientific mystery into a generalized phenomenon. It means that the characteristics we identified, the stability, the resistance, the non-outgassing shell, may be the standard operational design for interstellar probes, optimizing for longevity and stealth. It is an engineering choice. Why waste energy on propulsion or communication when you can rely on the natural, chaotic forces of stellar ejection to distribute your network of sensors, a billion-year-long passive broadcast? We are watching the galaxy not as a dead, empty place, but as a space quietly filled with the long, patient sweep of deep-time technology. This knowledge should induce not anxiety, but a calm sense of scale. The universe is vast, and its inhabitants, if they are advanced, are patient. They are not rushing, they are not shouting, they are simply weaving their quiet way through the star systems. The very fact that we found 2 of them suggests we have just stepped onto a cosmic highway, and the traffic flow is considerable. This profound recognition of the density of interstellar movement forces us to move beyond the physical characteristics of the vessel and begin to contemplate its possible purpose. If this object is not merely an accident, but a piece of technology, what possible task could require a journey of millions of years and a design optimized for perfect, silent containment? The answer may lie in the realm of information transfer, a concept known as panspermia, but with a technological rather than biological core. This takes us from the physics of motion to the philosophy of cosmic meaning. But this was only the statistical awakening. The next segment takes the quiet, enduring silence of 3I Atlas and compares it to the most enduring mystery of our own deep past. The subtle, quiet clues left behind by the distant Earth, the recognition of the dark fleet, the sheer, quiet, statistical density of interstellar objects passing through our space demands that we move from analyzing the physical structure of 3I Atlas to contemplating its potential purpose. If this object is an engineered shell, designed for stability and containment over vast distances, what could be the cargo of such a patient, silent vessel? This leads us to the concept of technological panspermia, a profound twist on the theory that life on Earth may have originated from microbial spores or other organic material hitchhiking on natural space debris. Panspermia, meaning seeds everywhere, suggests that life is not unique to Earth, but is a common, enduring force in the galaxy, spread by cosmic chance. Technological panspermia elevates this idea by suggesting that intelligent civilizations, recognizing the fragility of their own existence and the long, deep time scale of the universe, might purposely engineer resilient, self-contained capsules designed to transfer information, technology, or even genetic blueprints to emerging star systems. The very resilience of 3I Atlas, its lack of volatile materials, its stable, damped spin, its ability to survive a journey of millions of years, makes it an ideal candidate for such a mission. Imagine the engineering constraints of such a long-haul vessel. You are designing something that must survive not for a few years, but for 10,000 generations. It must withstand the constant bombardment of cosmic rays, the subtle erosive power of interstellar dust, and the radical temperature swings of passing between star systems. A message broadcast on radio waves might fade or be missed. A physical object, a silent archive, endures. It is the ultimate form of passive communication, a whisper that travels across light years and waits patiently for a technologically mature civilization to find it. This is the evidence that deepens. The object's characteristics are not those of a random hunk of rock, but of a deliberately hardened information package. If you were to send a probe into the far future, you wouldn't use computer chips that degrade over a few hundred years. You would likely use stable, crystalline structures, perhaps a three-dimensional lattice capable of storing vast amounts of data in a non-volatile, molecular form, or even a self-replicating molecular machine, a form of nanotechnology engineered for ultimate endurance. The hard, silent shell of 3I Atlas would simply be the cosmic equivalent of the protective packaging, the refractory material being the ideal insulator and shield against the energetic chaos of space. We can connect this to a modern scientific concept known as the archivist paradox. In our own time, we struggle with the problem of storing digital information for even a few decades. How do we ensure that the knowledge we create today survives 1,000 years? For an advanced civilization, the challenge is amplified 1,000,000 times over. The solution might be to bypass the electromagnetic spectrum and rely on physical transport of hyperdense, durable archives. These probes, like 3I Atlas, would be launched with a slight hyperbolic velocity, ensuring they disperse into the galactic void, effectively seeding the cosmic environment with time capsules. This is the cosmic perspective of a civilization mastering deep time longevity. The mythic echo here is the story of the seed ship or the Ark, a concept found in countless ancient flood myths and creation tales, where a vessel is built with immense endurance to carry the essential elements of a civilization or life itself across a vast, destructive gap in time or space. 3I Atlas is a scientific version of this ark, a small solitary vessel carrying the essence of a distant star system's knowledge. Its silence is a feature, not a flaw. It is waiting for a civilization, perhaps us, to reach the level of technology capable of safely opening its incredibly resilient shell without destroying the delicate information housed within. This forces a moment of existential reflection. If 3I Atlas contains an archive, what kind of information would an ancient, advanced civilization prioritize sending across the galaxy? Would it be a record of their history, a warning of a galactic catastrophe, or perhaps an instructional manual for complex, self-sustaining technology? The message might be so dense, so non-human in its form, that we wouldn't recognize it as data even if we had the core material in our labs. It could be written in the very structure of matter, a kind of quantum calligraphy that requires a molecular-level microscope to read. The quiet humor in this is that we, the eager scientists of a relatively young star system, are desperately chasing after what we perceive to be a piece of cosmic trash, a non-outgassing rock, when we may be chasing the most profound artifact in the galaxy, the equivalent of finding the Library of Alexandria floating in the deep ocean, but encased in a kilometer-thick shell of unyielding metal and carbon. Our difficulty in characterizing it is the very proof of its sophistication. It is a technological design so effective that it blends seamlessly with the stochastic noise of the universe. The statistical reality of the dark fleet suggests that these probes are not rare, one-off events, but a common phenomenon of an active, populated galaxy. This means that our solar system may, in the past, have been visited by dozens, or even hundreds, of such silent, archival vessels, each one planting a seed of technological panspermia in our gravitational well before moving onward into the vast, dark fleet. We are merely the first generation to have the technology to glimpse the second one. Now, we must transition from the object's potential purpose to the history of our own planet, the very Earth beneath our feet, and ask a disquieting question. If advanced life is indeed seeding the galaxy with these probes, how long have they been at it? And is it possible that a previous visitor, an ancient analog to 3I Atlas, might have arrived during a far earlier, more chaotic epoch of Earth's existence and left a physical trace that remains hidden to this day? This quiet search for the silent archive is the human reflection upon cosmic possibility. The next step is a deep dive into the geological record of our own planet, where we search for an echo of a time when the traffic of the dark fleet might have left something more than a brief flyby. We must look for the echoes from the past, the quiet, enduring scars that suggest a visitation long ago, when no human eye was there to witness the approach of the strange vessels. If the slingshot of the sleeping star was the engineering solution for the launch, and the refractory shell is the solution for the journey's survival, then we must now peer inside the engineered silence of 3I Atlas to consider what kind of technology could justify such immense patience and deep time investment. The silence is not merely a lack of radio emission. It suggests a technology that operates on principles far more subtle than electromagnetic radiation. We are led, quietly, to the concept of zero-point field technology, a theoretical framework that operates on the very fabric of space-time. The zero-point field is a concept from quantum mechanics that suggests even the deepest vacuum of space is not truly empty, but is instead teeming with vast, fluctuating, virtual energy. This energy, the ground state of the quantum field, is thought to be the most immense and pervasive energy reservoir in the entire universe. For a civilization capable of mastering stellar-scale mechanics, learning to tap or manipulate this ocean of quantum foam would be the ultimate technological leap, a way to draw energy directly from the vacuum, or perhaps to use its subtle influence for detection and communication. This is the evidence that deepens. The persistent, inexplicable, stable, single-axis spin of 3I Atlas may not be solely for structural integrity. It might be a component of a zero-point energy collector or a quantum sensor. A civilization seeking to passively observe an emerging star system without betraying its presence through loud radio waves would rely on something that operates below the threshold of our current detection capabilities. They would rely on field physics, rather than particle physics, to interact with the environment. The first anomaly of this internal technology is the energy imbalance. An object traveling through space for millions of years requires an internal power source for sensors, archival storage, and maintaining the structural integrity of the shell against the slow degradation of the void. Yet, the object shows no sign of thermal radiation or any internal heat source that would indicate a radioactive decay generator or a conventional reactor. The only explanation is a technology that draws its power from a source so efficient, so perfectly coupled to the vacuum, that its energy signature is virtually zero, blending seamlessly with the cold background noise of space. This is where the zero-point field provides a plausible answer, a power source that is perfectly silent and inexhaustible, utilizing the free energy of the vacuum. This leads to a profound cosmic perspective. If 3I Atlas is manipulating the zero-point field, its primary function might be a form of hypersensitive space-time detection. Instead of looking for light, it might be looking for gravitational ripples, quantum fluctuations, or the subtle acoustic signatures of large-scale industrial activities on a planet. The probe wouldn't be looking at us. It would be listening to the fabric of reality around us. Its stable spin could be a necessary condition for its sensors to establish a stable reference frame relative to the turbulent quantum vacuum. The mythic echo here is the concept of the aura, or the ether. For centuries, mystics and early scientists believed in an invisible, all-pervading medium that linked all things. The zero-point field is the scientific realization of this ancient idea. An object mastering this field is essentially mastering the aura of the universe, achieving a form of cosmic invisibility by interacting only at the most fundamental, energetic level of reality. The probe is not moving through space. It is subtly manipulating the space around it to facilitate its silent passage and observation. The quiet humor in our current predicament is the technological blindness. We are looking for the sound of a drum when the message is being transmitted through the subtle movement of a silent, perfectly tuned string. Our instruments, our radio telescopes and infrared cameras are tuned to detect the clumsy, loud technology of a younger civilization, like our own. The true message of the Dark Fleet lies in the frequencies we cannot yet hear, the subtle, quiet whisper of the zero-point field. This quiet pursuit leads to a moment of human reflection. What kind of civilization would prioritize this level of stealth and subtlety? Not a civilization engaged in warfare or conquest, which requires loud, overt demonstrations of power. Rather, a civilization dedicated to pure, passive observation and long-term archival, one that views the galactic environment not as a battlefield, but as a vast, complex ecosystem to be studied without contamination. The engineered silence of 3I Atlas is not malicious, it is simply scientific. To summarize the three anomalies associated with the internal mechanism: 1. Energy imbalance, no detectable heat source. 2. Rotational coupling, the stable spin being necessary for field manipulation. And 3. Quantum camouflage, operating outside the electromagnetic spectrum. This pattern suggests an architecture designed to minimize energetic signature while maximizing the duration and sensitivity of its observational mission. The quiet rhythm of this segment draws to a close with a final, subtle query. If the probe is powered by the zero-point field and is designed for observation, what exactly is it watching? The most critical piece of information for any interstellar civilization is the presence of water, the undeniable cradle of carbon-based life. The next segment will focus on the ultimate vulnerability of our own world and how a silent observer would analyze the planet's most unique and crucial feature. The long, silent journey continues, now focused on the single, most important observation. To understand this quiet, powerful mastery, we must look at the key ingredient that makes our world so visible to any life-detecting probe: the liquid water that defines our existence. We have explored the engineering marvels that brought 3I Atlas into our neighborhood, the slingshot of the sleeping star and the whisper of the zero-point field, a system designed for ultimate stealth and survival. Now, we must turn the probe's quiet, quantum gaze back upon our home world. If this vessel is indeed a passive, archival reconnaissance unit, its singular, most critical task is to identify and characterize the presence of liquid water, the undeniable, crucial signature of a planet capable of fostering life as we know it. Our world, the blue marble, broadcasts its identity across the vastness of space, not with loud radio signals, but with a subtle, unmistakable, spectral signature. When an astronomer observes a planet transiting its star, the light filtering through the planet's atmosphere reveals the presence of specific molecules: oxygen, methane, carbon dioxide, and, most importantly, water vapor. The combination of oxygen and methane in disequilibrium, meaning they shouldn't coexist for long periods without biological replenishment, is the telltale sign of life. But for a quick, passive flyby probe like 3I Atlas, the sheer abundance of surface water is the easiest and most powerful piece of evidence. This is the evidence that deepens our understanding of the probe's function. It must contain incredibly sensitive, passive spectrographic sensors, capable of analyzing the light reflected off our planet. Imagine the probe's sensors, powered by the zero-point field, quietly measuring the reflected sunlight from Earth. What they would find is a dominant signature from the planet's surface that is unique in the solar system, the dark, absorbing signature of liquid water across 71% of the surface, segmented by the reflective signature of land masses. This is the first anomaly that immediately flags Earth as a high-priority target, the liquid water fraction, the vast, uncontained presence of the solvent of life. The cosmic perspective on this is profound. In the 400 billion stars of the Milky Way, the sheer rarity of a planet retaining massive amounts of liquid water on its surface is the greatest cosmic lottery win. Most planets either lose their water to space due to lack of a magnetic field, or the water is locked up as ice beneath the surface, or it exists only as superheated steam. Earth is a wet exception, a blue, glittering oasis. For a passive probe, the signature of the blue marble is the ultimate beacon, a scientific X marking the spot. The probe's mission, then, is likely not just to detect water, but to analyze its stability and its history. This would involve measuring the slight isotopic differences in the water, the ratio of deuterium, or heavy water, to normal hydrogen water. This ratio is a quiet, powerful geological clock, telling the probe how much water the planet has lost over billions of years and how stable its hydrosphere is. A low deuterium to hydrogen ratio suggests a planet that has successfully retained its original water supply, confirming the planet's long-term habitability. The refractory shell of 3I Atlas may be designed to protect sensors capable of making this incredibly delicate measurement from the turbulence of its long journey. The mythic echo that resonates with this observation is the ancient reverence for the ocean as the source of all life. In countless mythologies, the sea is the primordial soup, the deep, dark, nourishing mother. The alien probe, a piece of technological panspermia from a distant star, is merely fulfilling a scientific mandate: to find the water, to find the source. Its quiet arrival is the modern, scientific analogue of the old gods peering down upon the Earth's watery cradle. This leads to a moment of existential reflection. We worry about sending loud signals, but the most profound message we send to the universe is simply our appearance, the shimmering, blue, wet planet against the dark backdrop of space. The engineered silence of 3I Atlas is the appropriate response to this observation. If a planet is already broadcasting its life-bearing capability so clearly, why waste energy broadcasting a reply? The job of the probe is complete. Target acquired, data archived. The quiet humor in this analysis is that we spend immense resources to search for exoplanets that might have water, yet we are constantly being scrutinized by devices designed to recognize a world that has water everywhere. The most powerful beacon of our existence is not a constructed antenna on the ground, but the 71% of our surface covered by the ocean. To summarize the 3 critical observations the probe would make about Earth. 1. The liquid water fraction, massive surface oceans. 2. The atmospheric disequilibrium, oxygen and methane coexisting. And 3. The isotopic signature, low deuterium ratio, indicating long-term stability. These 3 pieces of data, collected silently and rapidly by a passing probe, like 3I Atlas, would confirm our status as a rare, valuable, and stable life-bearing world. The purpose of the probe has been quietly revealed. It is a galactic geochemist, a quiet sentinel dedicated to cataloguing the wet worlds. Now that the probe has confirmed the existence of this wet world, The next step in its long, silent program must be to analyze the conditions necessary for its data to be retrieved. This requires a transition from the analysis of the planetary surface to the analysis of the civilization itself, specifically, our level of energetic mastery. Having traced the possibility of technological panspermia, the idea that objects like 3I Atlas are purposeful, hardened archives, we must now search for the echoes from the past, the quiet historical footprint of the dark fleet in our own planet's geological record. If interstellar probes are indeed constantly traversing the galaxy, it is statistically inevitable that at least one of them, perhaps millions of years ago, would have made a direct, catastrophic impact on Earth. The question is, would such an impact leave a signature that an engineered object would make, distinct from the impact signature of a common, natural asteroid or comet? We must travel back in time, nearly 12,800 years ago, to an abrupt, puzzling period of global climate disruption known as the Younger Dryas. This was a sudden, dramatic reversal of the warming trend that was pulling Earth out of the last ice age. Temperatures plummeted back to near glacial conditions. Vast megafauna like the woolly mammoths vanished from the Americas, and early human cultures across North America and Europe experienced significant disruption. The cause of this sudden deep freeze remains one of the greatest enduring puzzles in paleoclimatology. The leading theory, and the one that quietly connects to the possibility of an ancient, impacting 3I Atlas analog, is the Younger Dryas impact hypothesis. This proposes that a massive cosmic impact event, perhaps a comet or an asteroid, or a fragmented swarm of such objects, struck the Earth's atmosphere or surface, causing widespread wildfires and releasing massive amounts of dust and vapor into the upper atmosphere. This atmospheric shroud would have blocked sunlight, leading to the rapid cooling that defines the period. But here is where the evidence deepens with a strange, subtle geological signature. Across a vast, 300 million square kilometer area spanning 3 continents, scientists have identified a thin layer of sediment known as the Younger Dryas boundary layer, which contains a unique, unsettling suite of materials. These materials are the 3 anomalies of the deep past. 1. Billions of nanodiamonds, formed under the immense, brief pressures of hypervelocity impact. 2. Unusual concentrations of platinum and iridium, elements rare in the Earth's crust, but common in certain space objects. And 3. The presence of microscopic spheres of carbon that indicate massive, sudden wildfires and combustion. These are the physical clues of a catastrophic impact. Now, let us introduce the subtle paradox that elevates this event into the realm of our cosmic inquiry. When scientists analyzed the chemical fingerprint of the impactor that struck the Earth during the Younger Dryas, they found the ratio of certain noble metals did not perfectly match the known composition of common, volatile comets or typical iron-nickel asteroids. The signature was unusually rich in certain refractory elements, suggesting a source material that was denser, harder, and less volatile than the average celestial wanderer. This composition is precisely what we would expect if the impactor was an older, slower, and perhaps larger version of 3I Atlas, a hyper-hardened archive or probe that had lost all its volatile elements and was composed almost entirely of refractory material designed for the long interstellar haul. This connects us to a powerful mythic echo of the fallen star or the heavenly hammer that disrupts human civilization. Across cultures that survived the Younger Dryas, there are indigenous narratives, the Native American tales of the star that fell, that speak of a terrifying event of fire and ice, a sudden and profound change that came from the sky. These are the human reflections upon a colossal, catastrophic encounter with the Dark Fleet. The myth is not just about a big rock hitting the planet. It is about a cosmic intervention that reshaped the world, carrying a sense of deliberate, profound change. This forces a moment of existential reflection. If an engineered object impacted the Earth, what was its purpose in the final, catastrophic moments? Did the probe, having successfully traveled for millions of years, malfunction upon entry? Was the impact itself intentional, a form of pre-programmed, sacrificial seeding, where the vessel was designed to shatter upon impact, dispersing its archived contents, perhaps microscopic nano-replicators or hardy genetic codes, across the now fertile, thawing planet? The catastrophic cooling, which caused the extinction of the megafauna, may have been an unintended side effect of the impactor's incredibly resilient, refractory shell. The quiet humor in this scenario is that the Earth was, at the time of the Younger Dryas, roughly 12,800 years too young to read the message. Our ancestors survived the ensuing deep freeze, but the potential technological archive was scattered and pulverized, hidden now in the nanodiamonds and platinum spikes of the boundary layer, waiting for our science to recognize it as something more than just cosmic shrapnel. The message was delivered, but the recipients were not yet literate enough to read the language of engineered containment. This concept highlights the ultimate patience and perhaps the cosmic indifference of the alien technology. The Dark Fleet is simply seeding the galaxy based on probability, not on the precise timing of civilization. The refractory composition of the object that caused the Younger Dryas may be the very chemical signature of the engineered shell designed to survive interstellar passage, making it a ghost of an object. Like 3I Atlas, we are left with the gentle, looping transition back to the present. The subtle, silent passage of 3I Atlas today is merely the peaceful analogue of the catastrophic event of the deep past. The velocity, the containment, and the structural integrity we observe now are the quiet, functional aspects of a system that once, long ago, manifested as a geological trauma. The scar of the Younger Dryas is perhaps the oldest, most powerful piece of evidence that deepens our suspicion that the traffic of the Dark Fleet is not a new phenomenon, but an ancient, ongoing strategy of galactic reconnaissance and archival dispersal. To understand the present, we had to look at the deep past. Now, we must turn our gaze from the geological scars back to the vessel itself and begin to consider what kind of propulsion system would be required to launch a Dark Fleet object on a hyperbolic trajectory across such vast cosmological distances. The recognition of the Dark Fleet and the potential for technological panspermia, perhaps even scarring our own deep past with an impact during the Younger Dryas, forces us to step back and ask the most fundamental engineering question: how did it get here? An object, like 3I Atlas, traversing the galaxy on a hyperbolic path, requires an initial propulsion mechanism capable of overcoming the gravitational tether of its home star and achieving the immense velocities necessary for interstellar travel. We are now contemplating the propulsion of the Dark Fleet, a silent, powerful system we call the slingshot of the sleeping star. Conventional propulsion, such as chemical rockets, is entirely insufficient for this task. To push even a small, refractory mass to the tens of kilometers per second required for interstellar escape velocity would necessitate a fuel mass that dwarfs the payload defying the observed compactness and stability of the object. The engineering of the Dark Fleet must therefore rely on non-conventional methods, systems that harness the immense, natural forces of the cosmos with supreme efficiency. This is the evidence that deepens our understanding of its non-natural origin, as it demands a level of physical mastery we have yet to achieve. One of the most elegant and likely methods for achieving this escape velocity is through gravitational slingshot maneuvers, but executed on a scale far beyond our current practice. Imagine a star system, the home of 3I Atlas, possessing a binary star companion, or a massive, previously ejected rogue gas giant. A civilization could precisely time the launch of its passive probe to pass incredibly close to this massive object, using the planet's immense gravitational pull to redirect and accelerate the probe, flinging it out of the system at a hyperbolic velocity. This technique, which we use on a small scale for our own interplanetary missions, becomes a cosmic catapult when scaled up to a massive star or planet. This leads to the first anomaly in the design of the sleeping star technology, the requirement for ultimate structural resilience. The stresses imposed on a vessel during a close-range gravitational slingshot around a gas giant traveling at high speed would be enormous, capable of shattering any naturally formed comet or asteroid. The fact that 3I Atlas appears to be structurally intact, with its stable, single-axis spin and non-outgassing shell, is not just proof of durability in the interstellar void, but proof of its survival during a catastrophic launch sequence from its home system. Its stability is an engineered memory of a violent, high-stress origin event. The cosmic perspective here is one of profound patience. The civilization that launched 3I Atlas understood that their mission was not a sprint, but a marathon of light years. They did not need to accelerate the probe continuously. They simply needed to impart a single, powerful, initial thrust, and then rely on interstellar inertia to carry the vessel for the next few million years. This passive approach is the hallmark of deep-time technology, an engineering philosophy that uses minimal energy for maximal longevity. The energy for the journey was borrowed entirely from the mass and velocity of a sleeping star or a giant planet. This concept holds a powerful mythic echo in the ancient idea of celestial mechanization. In many old cultures, gods or celestial beings were often depicted as using the motions of the stars and planets themselves to achieve great feats. The sky was seen as a colossal living machine. The slingshot of the sleeping star is the scientific reality of this myth, a technological civilization using the gravitational forces of their own star system as a propulsion system, an incredibly complex game of cosmic pool where the probe is struck precisely to achieve the maximum exit velocity. The quiet humor resides in the sheer scale of the wastefulness. From a terrestrial viewpoint, this is the most energy-intensive launch possible. But for a galactic civilization with access to star system engineering, the energy of a gas giant's orbit is essentially free and limitless. The ultimate luxury in propulsion is not the power of the engine, but the ability to harness the power of a whole planetary system. We must also consider the role of radiation pressure from the launch star. If the probe's outer shell, the refractory material we have discussed, was also engineered to function briefly as a light sail, the intense radiation from its home star during the slingshot maneuver could have provided the final, critical boost in velocity, adding to the object's hyperbolic escape. This connects the two known interstellar objects, Oumuamua, potentially a light sail, and 3I Atlas, perhaps a light sail capsule, designed not for maneuverability, but for a single, powerful push that sets it on its million-year glide. This is the human reflection. We are currently developing fusion drives and plasma rockets, trying to fight gravity in space with immense energy. An advanced galactic civilization simply uses them. The silence of 3I Atlas is the ultimate technological flex. The proof that the hardest part of the journey, the launch, was achieved through a sublime understanding and utilization of four-dimensional physics, where time, space, and gravity are the fuel. The engineering choice to rely on the slingshot model has a profound implication for its arrival. Because it was simply flung out, its trajectory across the galactic plane is essentially random. The fact that its path intersected with our tiny solar system is a cosmic lottery ticket, a pure, silent accident of physics. It underscores the patience of the technological panspermia strategy. Launch enough of these silent capsules, and eventually, purely by chance, a few will drift into the orbit of an emerging star system. This gentle rhythm leads us to the next, quiet stage of our inquiry. If the launch was executed with such incredible precision and patience, the object must have been designed to serve a singular, long-term purpose. What could be the nature of the hidden technology inside the refractory shell? We must now contemplate the possibility that the engineered silence is not merely a shield, but a signal that only certain frequencies of reality can detect. The slingshot accelerated the vessel, the shell protected the cargo, and the next segment asks what the cargo is doing now. In the profound, quiet, dark, the answer may lie in the realm of subtle energy fields and the very fabric of space-time. Having used the deep time mirror to reflect on the immense longevity and stability of the architects, we must now leave the realm of philosophical speculation and return to the domain of pure numbers. The final, most subtle clue regarding the origin of 3I Atlas is hidden not in its composition or its spin, but in the mathematics of its orbit when plotted against the grand scale of the Milky Way galaxy. This is the galactic coordinate anomaly, an unsettling piece of data that suggests the vessel did not originate from a star system close to our own. To appreciate this, we must shift our perspective once more. Stop imagining the solar system as a three-dimensional sphere, and instead visualize it as part of a colossal, flat galactic disk, a spinning spiral of several 100 billion stars. Everything we see locally, our sun, our neighbor stars, and their planets, is orbiting the galactic center in a relatively flat plane, much like cars on a colossal, slow-moving carousel. Objects moving within this plane are considered native to our immediate galactic neighborhood. This is the evidence that deepens our suspicion. When astronomers calculated the incoming trajectory of 3I Atlas and its hyperbolic escape velocity, they noted something profoundly unusual about its path relative to the galactic plane. Most objects that are naturally ejected from nearby star systems tend to stay close to this plane, as the stars that launched them are also within it. 3I Atlas, however, appears to be coming in at an unusually high inclination, meaning its trajectory is steeply angled, cutting across the plane rather than riding along it. This high inclination is the first anomaly of the galactic coordinates. The object is not just from another star, but seemingly from a different region of the galaxy altogether, perhaps from the galactic halo, the vast, spherical cloud of old stars and dark matter that envelops the flat disk. The stellar population in the halo is ancient, metal-poor, and orbits in highly eccentric, inclined paths, entirely distinct from the younger, metal-rich stars of the disk. If 3I Atlas originated in the halo, it suggests an extreme antiquity and a different chemical composition for its home system, adding further weight to the deep time mirror reflection. The cosmic perspective here is breathtaking. If the probe came from the galactic halo, it implies a journey not of just a few tens of light years across the local spiral arm, but a traversal of hundreds of thousands of light years, cutting across the massive gravitational field of the galactic disk. This kind of journey demands an even greater degree of structural resilience and propulsion mastery than we previously imagined. The refractory shell must not only resist the void but also the occasional, intense bursts of cosmic rays and the chaotic gravitational tugs from passing spiral arms. This vast, cross-galactic journey reinforces the idea that the object is not a piece of debris, but an engineered, purposeful vessel built for the largest possible scales of time and space. This grand trajectory connects to a powerful mythic echo found in tales of wanderers and interdimensional travelers, beings who move between the planes of existence or travel from the very edge of the known universe. The highly inclined orbit of 3I Atlas is the scientific realization of this myth, a traveler that ignores the local gravitational rules of the road, moving with a kind of cosmic freedom that suggests its origins are far beyond our familiar neighborhood. It did not drift in, it was sent across a vast cosmological gulf. The quiet humor in this is that the architects, in their immense foresight, may have intentionally targeted star systems like ours with objects traveling on high-inclination trajectories. Why? Because this angle minimizes the time spent in the dense, electromagnetically noisy galactic plane, which could interfere with the long-term functioning of their zero-point field technology. The highly inclined orbit, therefore, is not a coincidence. It is a feature of a stealth-optimized trajectory, a pre-programmed galactic flyover designed to minimize interaction with the interstellar medium's chaotic forces. This leads to a moment of existential reflection. The galactic coordinate anomaly forces us to accept that the civilization that created 3I Atlas views our entire local star neighborhood, our spiral arm, the stars we call neighbors, as merely a small, temporary region to be passed through. Their operational space is the entire Milky Way, and their technology is built to handle the forces and timescales of that immense, spinning disk. This object is a piece of pan-galactic technology, a fragment of a communication network that is woven across the vast, chaotic structure of the galaxy. To summarize the three implications of the galactic coordinate anomaly: 1. The extreme antiquity, suggesting an origin in the galactic halo or an ancient population. 2. The stealth trajectory, a high inclination, minimizes electromagnetic noise and exposure to dense stellar fields. And 3. The pan-galactic scope. The builders operate across the full scale of the Milky Way, viewing our solar system as a transient target. The journey of 3I Atlas is now nearing its climax as it reaches its closest approach to the Sun before turning away forever. We have confirmed its physics, its resilience, and its vast trajectory. The final pieces of this quiet, cosmic puzzle must now address the most immediate and profound question. Why did our telescopes detect 3I Atlas in the first place when it was designed for such ultimate stealth? The answer, ironically, lies in the slow dissolution of its carefully constructed shell. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3I, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object. No debris. No passing dust plume large enough to explain it. just empty sky. Yet the Skycam had caught something ablur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something, not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from High Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3i Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one? It's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3i Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, Somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, They all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "it's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form. Skin faintly iridescent, eyes reflecting the green-gold spectrum of 3i Atlas. Life had achieved coherence. But the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The patterns spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened, air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorrell stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response. The universe just said thank you." After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time. A pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. its replication. We've become the architect's handwriting. Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, A senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today. Tweets unsent, secrets bent, silence hums with government." It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, They spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for "please don't mention the heartbeat." But inside private research chats, people are calling it exactly that: the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental, but coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. We have traced the silent journey of 3I Atlas from its violent launch via the slingshot of the sleeping star to its quiet, stealthy passage powered by the whisper of the zero-point field. We have analyzed its refractory shell, understood its role in the Dark Fleet's ancient mission of technological panspermia, and recognized the profound existential obligation its presence places upon us. We conclude this long, quiet reflection by experiencing the quiet resonance, the moment the vastness of the cosmos settles within the listening heart. The vessel is now far beyond the orbit of Pluto, its light indistinguishable from the background stars, its hyperbolic trajectory carrying it onward toward the next star system, perpetually broadcasting its signal of the encoded dark. Its encounter with our world was less a visit and more a statistical necessity, a brief, accidental intersection of an ancient purpose and a nascent civilization. The mystery of the object's origin has deepened into a mystery of cosmic meaning. This quiet resonance begins with the profound understanding of deep time. The architects designed for millions of years, acknowledging the brevity of any single civilization and the enduring nature of the physical universe. Their longevity is our ultimate hope. Their engineered silence is the template for our own future. A civilization that has mastered its resources, minimized its conflict, and achieved the planetary unity necessary to survive the perilous transition to Type 1 maturity. The probe's existence is the proof that the universe rewards patience and efficiency. The cosmic perspective here is one of vast, shared legacy. We are not isolated, but merely the youngest members of a very old, very quiet, galactic society. Our task is to prove ourselves worthy of the inheritance, to unlock the language of pure logic, to heed the potential warning of the shadow in the halo, and to eventually become the next generation of starseeders, continuing the archival work of the architects into the next billion-year cycle. Our future is interwoven with the silent purpose of the object that just passed us by. The mythic echo that settles upon us now is the final, comforting realization that the entire cosmos is one single, vast, unified machine. The music of the spheres is not a loud melody, but the quiet resonance of gravity, mathematics, and profound, engineered stability. The most advanced technology in the universe looks like a silent rock, and the most important message is contained in the subtle dance of a prime number sequence. This leads to a final, unifying moment of existential reflection. The passage of 3I Atlas changes nothing physically about our star or our planet, yet it changes everything about our self-perception. We are no longer alone. We are challenged, we are observed, and we are offered a path of quiet, deliberate, species-level growth. The greatest lesson of the Dark Fleet is that the highest form of intelligence is not found in noise and conflict, but in the profound, enduring silence of mastery. We may already be part of the experiment. The journey into the quiet tension of the universe has concluded, but the resonance of this profound encounter will linger. The final hyperbolic kiss fades now into the deep, dark night, leaving us with a sense of immense, quiet wonder. And so the silent traveler, the piece of ancient, engineered resilience, slips back into the velvet dark, receding now, its velocity an unbreakable promise of finality. We have shared this quiet time contemplating its speed, its substance, its mission, and the profound, humbling questions it poses. Our ancestors survived chaos and darkness, and our endurance is our gift, a legacy honed by millennia of struggle. The history we have traced bends toward the possibility of a greater future, a Type 1 future, rooted not in loud conquest, but in quiet, unifying logic. The Earth continues its ancient, faithful orbit, a blue marble of liquid water and potential, waiting for its inhabitants to grow up. Sleep now, and may the vast, quiet wisdom of the architects be the gentle rhythm of your dreams. History bends, but never breaks. The light of the sun, however distant, always returns.